Hi everyone. So today would be the last exercise. So how many of you need to complete this exercise to get the bonus? All of you, or because you have to do 4 out of 5, right, to get the bonus? So this would be the last exercise. But before going to the last exercise, I'll give you the solution for the previous exercise. So for the exercise 4, so you have this architecture where you have multiple microservices and you have to deploy it using Kubernetes. And so each of these microservices has a pod and a service, and also the server microservice has 2 replicas as compared to the other microservices. And the interesting point over here was that these 3 individual microservices has to be exposed as a cluster IP, and the server microservice is a load balancer exposed. So the solution was quite simple. So if you have see the for the hello world deployment file, so it's also quite simple for the other microservices. So you can see over here you have to enter the name, the product description, like deployment, and then the labels. So what I saw in the most of the solution that the students were like writing over here the product description, and this product description is used by the Kubernetes to match it to the Kubernetes services. So if you specify something like over here product description, then in the services also it has to be product description. So over here. So if you mismatch these 2 things, so then the Kubernetes will not be able to send the request from the service to the actual pod which is running over there. So it's used by the Kubernetes service as a selector for which service this is, and then send the request to that particular pod itself. So the same was for the server microservice, and the only difference was that this has to be exposed as the load balancer, type load balancer. Yeah, so that's all about the last exercise. Does anyone have any questions related to it? So how did you felt it was difficult to deploy a Kubernetes cluster using kubeadm? I think some of you used directly the GKE, the Google Kubernetes engine, but it might not work with the exercise because we asked you to expose the Kubernetes services, Kubernetes API, which the GKE doesn't allow it. So that was the issue. So now we go to the next exercise, and for next exercise, you will require all the knowledge which you learned in the last 4 exercises. So like starting with the Kubernetes, Docker, all the microservices, everything. So it's a bit tricky, but yeah, let's see. So this is just to show you how the number of how the successful submissions for the exercises have been progressed so far. So initially in the first exercise, there were around 150 students, 150 groups. And for the last exercise, it dropped down to around 100. So you can see around 50, maybe they left or they felt it is difficult. So, yeah. So let's see the last exercise. So for the last exercise, we will be using OpenWhisk. So I hope you remember from the lecture from the function as a service how the OpenWhisk works. So within OpenWhisk, if you have to create a serverless function, so this is how it looks like. So you have a function main, you specify the main function, and then if you have certain parameters to it, like I'm specifying the name, so it's just a hello function which says hello, and then the name which you are passing it as a parameter. So like if you don't pass the parameter, then it would be hello world. And so this is all you require if you want to deploy a function within OpenWhisk. So this is all the part of the file you require. You don't have to specify anything else. So you can save it to hello.js and then you can deploy it. So I'll show you how also deployment works. So for deployment, we will be using the OpenWhisk CLI, which is called as the Whisk. And it is present over here on the GitHub. Within OpenWhisk CLI, so you have to configure 2 parameters. One is the API host, and the other is the authorization key. The API host is the API or the master node IP address plus the port number, and the authorization key is the username and the password combined together. So for example, so like over here, Whisk property set API host, the master node IP plus the port number, and then the authorization key, which is a combination of the username and the password. So there are other commands, like if you want to create a function on the OpenWhisk, you can specify using the whisk action create. So action within OpenWhisk, each function is called as an action. So if you have used AWS Lambda, so it's a Lambda function. So here it's an action within the OpenWhisk. So now if you remember from the last, we saved it as a hello.js file. And if now we will be creating this function over here with the hello. And if you want to invoke that function, so now you have deployed that function within OpenWhisk. So you can also invoke it using this command, whisk action invoke hello, and then you can specify the result. So the result says, so when you specify this parameter, so it's a blocking call. So your whisk CLI would wait for the result to come back from OpenWhisk, and then will show you. So like over here, I'm specifying the parameter. So you can also specify the parameter within for the invocation, like the name. So this is just to give you an overview of the whisk CLI, which we will be using as part of this exercise. So the next is the Helm. How many of you used Helm? Anyone? 1, 2. So if you remember in the last exercise, you have a lot of deployment files. So like for each microservices, there was one deployment file, and then there was also one service file for each of them. So if the application grows, then there would be a lot of more deployment files. So like over here, you can see deployment, secrets can also be there, the volumes can also be there, and it can become very big. So Helm is created by some open source community to reduce that part. So it acts as like a package manager. So like you specify the combination of certain deployment files required by your application, and that combination becomes a chart within the Helm. So like for example, in the last exercise, we have 4 microservices, and for each microservice we have a deployment and a service file. So then we have a combination of total 8 YAML files. So that combination together bundles up into a chart, and this chart you can deploy then with a single command from the Helm itself. So Helm deploy or Helm install that particular chart. So now if you want to pass from one user to another user, so you just have to tell that this is my chart name, just deploy it on your Kubernetes cluster. You don't have to give them the YAML files. And so you can also do some configuration within those YAML files, so you don't have to change them, like the port number or the image part. So that's also, you can configure it through the Helm itself. And lastly, there is a release. So like if you want to release your chart or your particular application YAML files for other users, so you can store them on a repository and then release it for the other people. So Helm has mainly 2 components. So one is the client, which is you. So you would be deploying the Helm on the Kubernetes, the YAML files on the Kubernetes cluster. And previously there was a Helm 2 version. So within the Helm 2 version, there was a component called as a tiller, which was required for the deployment of the application YAML files to the Kubernetes cluster. So what it was doing is it was taking the YAML file specified by you within the chart itself, and then converting those Helm chart values to the actual Kubernetes YAML file so that they can be deployed. As you can see, there is already a problem within that. So the tiller would have like a sudo access of the whole Kubernetes cluster. So that was the major problem why they removed within the Helm 3, which was released a few years back. So within the Helm 3, you don't have to specify the tiller or anything. So you just have the client itself, and the client is responsible for deploying it directly on the Kubernetes cluster. And the Helm library is the other component which is embedded within the Helm client itself only. So it provides the logic for executing all the Helm operations. Like it interfaces with the Kubernetes API servers, like to deploy, to install, to uninstall, everything. So any questions until here? So these are the 2 things which we will be using, the whisk CLI, the other is the Helm. The another important part is the OpenWhisk conductor actions. So do you remember what is OpenWhisk first? How many of you remember it, how OpenWhisk functions? So it's fine. So just remember that we have a application which within the application we have a different functions, and those functions can be deployed on the OpenWhisk, and the OpenWhisk is deployed on the Kubernetes cluster itself. So you have underneath the Kubernetes cluster, then on top of that Kubernetes cluster you have an OpenWhisk, and then within OpenWhisk you deploy the application functions. So and the conductor, so conductor actions. So if you have, let's say you have a function A and function B and function C. So you want to form a sequence of those functions. Function A calls function B calls function C. So forming that sequence is using this conductor actions, we call it. So let's say, for example, I have a function called triple.js. So it's a file. Within that particular file, we have a function which multiplies the value specified to that file or to that function by 3. Then we have an increment function which increments the value by 1. So now I want my conductor function to call these two. And so that's where we have this triple and increment function which will call one by one. So you can see over here, so it's action, so it's a triple action, so it goes to the triple function and it will pass the parameter specified by the user, so what value you want to triple it. And then once it is done, then it will pass on to the second stage, which is the action increment. So once I have the triple plus 1, then it passes to the second, which is returning back the actual result to the user itself. So this is how you can create it. So you have to specify that it's a conductor true. So once you invoke this conductor function, so let's say like I am invoking this triple and increment conductor function using this particular parameter value 3. So my output should be 3 into 3 plus 1, which is the value 10. So how it is working within the OpenWhisk. So once you invoke this, so you can see within the OpenWhisk multiple functions are created, and these functions are representing the functions which this conductor is invoking. So you can see we invoked this one, triple and increment, and then the triple would be there and the increment would be there. Triple for tripling the value and increment for adding the values. And then there are these 2 or 3 other functions as well, which are serving as an interfaces between the triple and increment function to the another triple and the increment function itself. So one function cannot directly call the other function itself. So we require these interfaces in between. And these interfaces are created by OpenWhisk automatically for you using the composers. So, and these, the first one is called as the primary, and the second, these red ones are called as the secondary actually. Yeah, so more details you can go there. So we will not be directly using these conductor functions. So we will have, because you can see it's already quite complex to build an application using these conductor functions. So therefore we have a library called as OpenWhisk Composer within the Node.js. So with this composer, so how you can do is you can define the OpenWhisk Composer, and then you can specify what functions I want to invoke. So let's say like over here, I have a if composer. So if says like if something is true, then goes to that function. If it's not, then goes to other function. So what it will do, it will first call this authenticate function, and if my particular function's output is success, then it will call the success function. Otherwise, it goes to the failure function itself. And over here, you can see I have also specified the code for that function. So this is the actual function code itself. This is the function code for success, and this is the function code for failure itself. And if it is true, this password, whatever the value is sent by to the first function, if it is true, then it goes to the success. Otherwise, it goes to the failure function. So this composition can be made from different combinators, and I showed you an example of the if combinator, but there are other combinators as well, like parallel, which we will be using as part of the exercise. So another thing which I can mention over here, so as part of this example which I show you over here, so this over here we are specifying the function definitions also as part of the name itself. But you can have the functions already created within the OpenWhisk, and then you can specify directly what my functions are or what my composition would consist of. So now how to deploy this composition function or composer function? So you just have to, if you have installed this OpenWhisk composer, then you can run this compose command and specify the composer function and convert it into a JSON file. And this JSON file will contain all the required compositions for the OpenWhisk to run. And once you have this JSON file, you can then deploy it using this command over here. Deploy, this would be your this composer function name, and specify the name of the file, and then -w, I'll tell you why, or -I, I'm using it for the insecure, because my OpenWhisk deployment is not secure. So if you want to have an OpenWhisk deployment secure, you have to give the certificates and everything. So because we are just deploying for the exercise, so we don't have to provide the certificates for SSL authentication. So that's why this -I is over here. And -w option authorizes the deploy command to override the existing definition. So there might be previous definition for the same function which you have created. So it will override those definitions if you specify this parameter. And for invocation, it's the same as the other invocation functions. So you have to call the invoke function, then the name of the function, then if you are passing any parameters to that function itself. So I briefly mentioned previously that we have the if combinator. The other combinator is the parallel composition. So if you want to run the two functions in parallel, so you use this particular combinator over here. So then these two functions like the check inventory and the detect fraud would be called parallel. It would be called in parallel by the composer function itself. So you can see the problem with the parallel composition. So if I am calling multiple parallel combinations, so I need to store or hold the intermediate results so that I can combine them together for the final result back to the user itself. And for that, I require access to a Redis instance, which is an in-memory database. And so that you have to deploy as part of this whole infrastructure where your intermediate access or intermediate results would be stored. So we will be using the parallel combinator. So you don't have to read about the others. But if you want to read about other combinators, there are many more. So you can go to this link over here. So now we come to the exercise 5, the main exercise. So these are the tools which I explained you before that would be used within the exercise 5 itself. So this is the overall architecture diagram. So if you remember, it's very similar to the last one, but instead of now the Kubernetes services, we have now the functions, or the microservices. Now we have individual functions instead of those microservices. So like hello world function, product URL, product price, and the product name. And there is this composer function which is calling all of these functions in parallel. So you would have to use the parallel composer over here. And then you have the Redis, which is for storing the intermediate result of all these functions and then combining them together and sending back to the client or the user. And all of these functions, not all, these three functions is accessing a database. In the last exercise, we mocked the data using the JSON file. But in this, we will be actually deploying the MongoDB, which they will be querying and getting the data and sending it back. So as part of this invocation, you can see there are multiple parameters which are required, like the OpenWhisk API host, the key, the name and the product ID as in the last exercise, plus the MongoDB host information, the database collection, the user and the password to query it to the MongoDB itself. So these are all the input parameters, and the output would be the same as the last exercise, like the welcome, the product price, product name, and the product URL. So this whole architecture I'm giving you, so you have to add in that architecture this part over here, which is missing. So you have to add another function, which is a group function, which would just say group, whatever the number is, application deployed using OpenWhisk. And you have to modify the composition that it uses the group value also when supplying back the result to the user itself, like the combination over here. The rest would be part of the whole code which I would be giving you. And the source code is present over here. So I don't want to give you as a zip file. So it's now on the GitHub. So you can download it from the GitHub. And within the source code, you have the main app folder. And then there are these, this will come back later. So this is for testing. And you have to add this group.js. And you have to modify the composition.js to include the group.js functions output and send back to the user. To show you an example of hello world, so it's a very simple hello world function, so which takes the parameter as the name, and then if the name is specified, then it returns the dictionary with the welcome and then the name, and then if it is not, then the default value, whatever you can specify over here. And it's important within the OpenWhisk that the return value is always a dictionary or a JSON. So you can see that the return value is always a JSON sent back from the OpenWhisk function itself. So similarly for the product price, so we have the similar kind of a function. So I'm not showing how we are reading the parameters. So we are reading the parameters over here. Then based on that, we query the MongoDB, or we create the MongoDB client. So based on the user, password, the host IP, everything. So we get the client over here. Once we get the client, we then check where my product is. So we search for the product ID specified by the user. And if product ID is matched, then we send back the product price for that particular product. The rest is just some error checkings if something is missing or something is not given as a parameter. Similarly, it would be for the product description and the product name. I'm not showing you that, so I'll only show about the composition. So within the composition function, it's very simple. So you have like this. So you specify the combinator as a parallel and what all parallel functions I have to invoke. So like the hello world, product price, product name, and the product URL. So the other function which I mentioned you briefly, the test OpenWhisk function, which is not required for the exercise, but it is for you to test your deployment. Once you deploy your whole application on the OpenWhisk itself, you know that there are a lot of parameters which needs to be sent. And so I created this test OpenWhisk function for you to use it to test your application, whether it is working or not. And for that, you have to, within that particular function itself, you can specify the API host information, which is the OpenWhisk API information. Then the Redis. So this Redis, you don't have to change it. So it should remains the same because we are using the Redis of the OpenWhisk. So this is the, by default, the URL of the OpenWhisk Redis. And the other information is the name, the name which will be welcome, and then this name, the product ID, MongoDB host IP, database collection, user, and password. So the host IP and the password is specified on the CloudCom server. So if you go over there, so the IP address which you have to use and the password. So you don't have to deploy the MongoDB, it's already deployed for you. So just specify the IP address and the password over here to test it if your application is working or not. So now the last part is the installation and running the application. So how you can install the OpenWhisk and how you can deploy the application consisting of all these functions on OpenWhisk. So for OpenWhisk, the first step is to have the Kubernetes cluster, which you did in the last exercise. But do check that maybe you require 2 virtual machines. So if you have created only with 2 virtual CPUs, so it might not be feasible for OpenWhisk to run on that. So you might want to join another virtual machine to that Kubernetes cluster. Then the next is installing the Helm and the Whisk CLI. So you can follow these commands for installation of the Helm and the Whisk. So be careful that these are only for the Linux and the AMD architecture. If you are running it on for a different architecture, so do check out that particular link for getting for a different architecture. And then you have to configure OpenWhisk. So how you want to configure the OpenWhisk, like which API host name is, what is my port number. And for that, for specifying the API host name, so you have to run the kubectl cluster info command on your Kubernetes cluster, check the IP address and specify it over here. Once you have it, then the next is deployment of the OpenWhisk, and it's very easy. So first you have to label all the nodes within the Kubernetes cluster as an invoker, and the next is adding the Helm repository, which is OpenWhisk repository. Firstly, do a update so that it can get all the chart values, and then deploy it using this command over here. So my cluster.yaml, which you have specified in the previous one over here, will be used to modify the OpenWhisk, which will be deployed within the Kubernetes cluster. And don't change this one. So this is usually the release name of the OpenWhisk, which is deployed on the Kubernetes cluster. So because we are using, I'm using this for checking if your OpenWhisk deployment is correct or not. So don't change this name. And it will usually take around 5 to 10 minutes, depending on how compute power your Kubernetes cluster is. So it might be less than 5 minutes also, but check around 5 to 10 minutes. And you can check the status of the deployment using this command. And lastly, for the step 5, you have to configure the Whisk CLI. And for that, you have to specify the API host, where is your master node public IP, and then the authorization. So authorization, this would remain the same. So you can specify exactly the same authorization as given over here. And once you have done this, then you can check if your Whisk CLI is configured properly or not by running this command. So you can configure this Whisk CLI either on the master node or on your local laptop also. So depending on from where you want to deploy the function to the OpenWhisk cluster. And then now the major part is for deploying the application. For that, you have to first install the OpenWhisk composer. So you can do it again on the control plane, which is the master node, or on your local laptop. Get the repository which has all the function codes, and edit this particular file for testing if your deployment is correct or not. So these two values are specified on the Cloud Conf server. And once you have done this, then you have to call this, I think, 4 commands for deploying each functions. So like hello world, product URL, product name, and product price. So this is the path for the hello world code, the product URL code, product name, and product price. For the hello world, by default, we are using the Node.js environment. So that's why I'm not specifying any container in which that function would be created. So it's by default the Node.js. But for the product URL, product name, and product price, so I'm using the Docker container environment specified by me. So over here, you can see the image name for that. You don't have to change it, so you can use the same name itself. And lastly, for composition, so you run the compose command to get the composition JSON file and then deploy it on the OpenWhisk cluster. And once you deploy it, you can then use the test OpenWhisk function to check if your application deployment is working or not. So using this particular command. So then if you run this command, you would see output like this over here. So this output is missing the 2 parts, which is the group part, which you have to add additionally, and the modification of the composition so that it will combine the group part and then send back the result. Yeah, so then the tasks, which I already mentioned, that you have to add an extra function, which is the group function, modify the composition.js, and the test OpenWhisk function for testing the application, and then the whole process, starting the Kubernetes, deploying the OpenWhisk, deploying the application, and testing if it is working or not. And you have to expose this port number 31001 for the OpenWhisk. So OpenWhisk uses the port number, this one. And for submission, it's the same as the last exercise, but we only require the IP address. So we don't require the image or the port number or anything. So just the IP address of the master node. And you will have the 2 weeks until, I think, 2nd of August to complete this exercise. Any questions? I think this exercise is a lot to do, but you will learn it over the space. So any questions from my side? That's all actually. So you want 3 weeks? Okay. Mm-hmm. So we can extend, actually, it's not an issue. So until 9th August. Okay, so I'll do that actually. So you would have 3 weeks for completion of this exercise. Yeah. Yeah, so you will get the bonus. So whoever have left on this exercise would have to do a lot, so I have to do everything. So then that's all from my side. Then see you next week. Thank you again.